Hi, this is MegaSplat development log number 12. We're getting very close to the 1.0 release. This is the 0.99 version. Hopefully this will be the last release before 1.0. It is very feature rich and contains some new features, some breaking changes that needed to be done before we get to a 1.0, and a bunch of fixes and tweaks and things like that. So first I'm going to talk about the breaking changes. There was a massive refactor to a couple of areas. One is the Vertex properties, which I'll talk about in a moment, and the other is the UV coordinates. So the UV coordinates was actually a simple change. The problem is there wasn't a great way to revision the data. So now what will happen is whenever you see a UV coordinate, you will see an X and a Y parameter. That was added because a user wanted to be able to scale the textures non-linearly for use with rectangular terrains. So all the UVs everywhere have been switched to 2 values now. So unfortunately, there's not a great way to revision these properties in Unity when they change type on a material. These actually get set back to default. So when you first open your scene in the 0.99 version, the first thing you're going to want to do is fix your texture scales because they're probably going to be way off. The other big breaking change is per text properties. So if you are familiar with per texture properties, what they are is a way to have texture or some type of values for each texture. You can have a lot of different textures, and you may want to control different values of them independently. For instance, in this scene, I'm using the displacement scale and up bias parameters on a per text basis so that I can make some textures essentially displace more than others or have up bias and others not. And I'm also using Parallax strength, which is part of a new tessellation feature. But what I basically did was refactor that whole system. Before it had a bunch of exclusions where if you had flow on, then you couldn't get other certain properties. And so now what I've done is refactor it to make it much cleaner, but that means that that data is going to get wiped out on your existing material if you have it. And so now what you have is a whole bunch of different options for Vertex properties that you can just select the ones you want. It will only sample the textures that it needs to, or rather the pixels that it needs to get this data, so it is more efficient. And you don't have to apply every property anymore when you turn on a particular set. They are very atomic. So that was a big change that I wanted to get in before ship because it's, I don't like breaking things basically. And so I want to get that all done before beta, before we move on. So I believe there was another thing. Let me just check my notes here. Yes, so I rearranged some of the data on both the mesh and the terrain formats. On the mesh, if you had painted flow direction in the past, what you would actually do is go into here and you would select the UV2 ZW component. And that's what you would paint the flow direction into. The problem is, the UV2 XY component. So the problem is that Unity will occasionally use UV2 XY for some ambient lighting information. Now, nobody had complained about this, but it's bound to happen eventually that somebody will have the right lighting combination with flow mapping and their lighting will be messed up. So I moved this to the UV2 ZW component now, which means that if you've painted flow mapping, you'll need to repaint it. Now, luckily, most people don't paint a lot of flow direction, and if they do, it's just a matter of coming down here and painting in a direction. It's not usually a big job. So the final change is to do with the terrain painter. So the terrain painter used to have one texture for the splat mapping data and one texture for the parameterizations, which are like the flow direction, puddles, things like that. So there's a parameter on there for dampening displacement. So if you're tessellating your terrain, you can go in and you can paint, hey, I would like the terrain less displaced here. I would like it to be flatter. And you can sort of seam out edges and things like that. I don't think anybody's really using this on terrain. It tends to be more of a mesh feature. But if you are, and you want to preserve your painting, what you can actually do is copy the data from the parameters textures blue channel to the splat controls alpha channel. That's where it's now stored. And so then the blue channel is now used to control wetness. So now that we've gotten past the breaking changes, these are also fully notated in the forums and will also be in the patch release notes. So if you have any trouble or questions about this, please come to the forums and let me know. But let's get on to the new features. So I'm in a new scene here. You can see I've got some puddles painted. The puddles are flowing. I've got some displacement going. Well, we have a couple new things. The first one I wanted to talk about is the paintable wetness. So for this to work, you have to have wetness turned on, which is a new shader compile option. And then you go over into your Vertex painter and you switch to the paint tab and you change your paint to the UV1W. So that's the essentially the alpha channel of UV1's component. On the terrain painter, there's a wetness tab and you just paint there. So when you turn on wetness, your terrain might be very shiny. What you might have to do is actually fill it with a value of 0 to remove any wetness painting. And then if I actually start painting wetness, you'll see that as I paint here, this terrain gets a little darker and more reflective. It gets more specular. And so if I move in here, you can see the difference on these rocks. They look like they're wet. So what this basically does is control a wetness parameter that interacts with the porosity of the surface. So if you think about a surface that is very smooth, like metal or plastic, they tend to not darken when they get wet. But something which is very porous, like the stone, darkens a lot. And what actually happens is that the water fills in little cracks in the microfacets, essentially, in all the tiny little details of the surface. And the more rough that surface is, the more the water fills in the spots, and therefore it darkens it just like it does when you have water over a surface, and it also increases the reflectivity of that surface. And so that's what's actually going on here. Now, porosity is automatically computed from the smoothness and metallic maps, but there's also a per texture control for porosity, so that you can actually control, basically bias it per texture, and there's also a global setting for it. So if you find that overall, like everything looks a little too dark, or you feel like it's not porous enough, you can control those settings on your shader. So if I flip back here, you'll see that there's a global porosity right here, which controls the overall porosity level, and then there's an option, which I do not have turned on right now, for let's find it here. And this, I feel like, is the last big refactor I need to do. This menu for the compiler has gotten so big that it's hard to find your way around it, and I need to organize this in some better way. I'm not sure what that is yet. There's now a ton of options for the compiler. So if you have suggestions on how to organize this, I'd love to hear it. So here's a new one, per texture noise strength, which lets you control the noise texture per texture. And what was I looking for? The per texture porosity control. Actually, that is under the per texture material. If you turn this on, you will get a porosity value for each surface in your per text properties. And you will also get a metallic and smoothness value in case you're not using texture maps for that. So I can change that global porosity, and what you'll see is that the amount of darkening caused by water is changed quite drastically. So about 0.4 is the recommended setting for this. That's based on Sebastian Lagarde's paper. I hope I'm saying that right. He's now a graphics programmer at Unity, but did a lot of work on puddles and porosity and things like that. And that's what most of this stuff is based off of, his work. And so finally, you'll see down here there is a global wetness slider, which allows you to basically just drench the whole terrain if you want, making it super wet and specular or not. So this could be used to basically, if you're doing a rain effect or something like that, you might want to bring this in a little bit just to kind of create the illusion that the whole area is wet. I think a big use for paintable wetness is going to be on caves and things like that, where you tend to have really wet surfaces. Also around water flows, it looks really nice because it creates that sort of darkening you expect to see when you have water coming over an area. So let's talk about another new feature. For ages, people have been asking me, hey, can you add alpha support because I want to cut a hole in my train? I've stated on the forums why I don't think this is the best way to achieve caves, but people still want it, and there may be other uses for this that I'm not aware of. So there is now an alpha mode, and you can switch your shader to basically be alpha or alpha test. And if you set it to alpha test, it's going to recompile, and it's going to recompile a version of this that is effectively clip mapped. Now, at first, this doesn't look any different, and that's because, well, we haven't painted any alpha information down. So to do that, we need an alpha array, and I've already created one here and assigned it. And what this is it's just a texture array like any other texture array. Notice there's also a for your macro texture. You can also have an alpha texture here. And these actually expect that the alpha channel is in the R value of the texture. Why didn't I put it in alpha? Well, if you compress your textures, they're going to be smaller on most platforms by using a compressed texture and having them be RGB. Since there's nothing else in the data, it doesn't really matter what channel they're in. So that seemed like a more logical packing than putting it into an alpha channel and then compressing the texture with a big black color values for no reason. So the array here, it would suck to have to create alpha textures for everything if we just want to make a hole. So what this array actually has in it is only 2 textures. And if we look at the array, go to my texture arrays here, you'll see I have an alpha black and alpha white texture there. And that my texture array for the alpha here just contains the black texture and the white texture. So when the texture array gets sampled and it goes out of bounds because we're looking at element 12, it will just get element 1. So what this means is the first texture in the texture array will be black and all the rest of them, will be white. So in alpha aspects, that means that the first texture will be cutting holes and the last texture, or all remaining textures, will be solid again. So what we've done basically is sacrifice one of our texture slots, and we've made a single pixel texture array with 2 pixels in it to basically allow us to do this. Now, if you wanted full alpha channels and things like that, you could do that. If you were doing something very different, maybe you're painting onto, some other reason you need that information. So we go to our custom brush, and then let's go to the single tab here and select our diffuse, and we'll paint, and you can see that it is now cutting away this area. And because we set it to alpha clip, we are seeing a hole that is clip mapped. If we set this to alpha test, then it would be an alpha hole, and you would see it sort of fade around the edges. But remember that when you draw things in alpha test, there's a lot of, in alpha blending mode, there's a lot more overhead in drawing things because you're blending. You also can't render deferred if you're using a deferred system for your lights. You have to render forward. So if you're doing this for holes, I would suggest using alpha clip, and then once you paint your hole, cover it up with whatever you're doing, you should be good. So I'm going to undo that, and I'm going to switch my material back to being not alpha tested. We'll compile that. What else do we have here? So I added a full deferred pass. So if you're rendering in deferred mode and you have a whole bunch of lights, it's actually going to draw the train in deferred. Before this version, it would have drawn the train as forward rendering, which means you would have drawn it once for each light that hits it. So if you're using lots of lights, that's a big improvement. Flip back to my notes. Okay, so Snow had some improvements done to it. The first is that we now have, so we can turn up our mount here on our Snow, bring our Snow in. We now have what's called a Snow up vector. And basically what this is the direction the snow is coming from. So before, we assumed that snow always came straight down. And what this means is that it would always sort of build up equally on each surface. But in this case, what I've done is change this vector so that it's sort of pointing down from the right here. And what this does is it means that we get more snow on this side than we do on this side. That it tends to build up here. So that creates sort of the wind direction, if you would, for your snow. And so that can give you a little bit more realism. If you have some really nice overhangs and you're expecting the player to stay maybe in this area, you could use that to your advantage to create a really nice effect. Let's see. In case you haven't seen it, I have this nice example of snow buildup, which you can enable here. And this actually shows you how to animate the snow in, and then actually get it to solidify. It turns more crystally and icy, which changes the specular properties, and then fade out. And you want it to come in more globally than you want it to fade out. When you come in, you want snow to build up so that it just sort of piles up over everything and smooths everything out. And when you want it to go out, you actually want it to melt off the top surfaces first. And so this animation is a little keyframed animation here that I've done in this little keyframe structure. It'll show you how to ramp in and out snow in the natural way. I think I might have showed that last time, but it's cool enough. I'll show it again. The other option that happened to snow is that there is an option now to draw the snow over the macro texture, snow over macro right here. So what this is useful for is you may have a terrain, you rendered the macro texture out, it doesn't have any snow on it, you want snow to build up in your game dynamically, you still want that to be in the macro texture, so you can apply the snow after you render the macro texture to make it build up over the whole scene regardless of what the macro texture says. Or you might have your snow already baked into your macro texture in which case you don't bother to do that. Let's see here. There was a common case that would mess people up, and it's been reported on the forums a couple times. It's technically user error, but it is a common one to make. So the problem is that when we open up the Vertex painter, it probably looks like this. Now recently I changed it so it at least opened in the custom tab first. But what happens is people come in here and they paint a bunch of color information trying to get something working, and they're like, why is it not painting? And what that does is mess up the blending that MegaSplat uses. So if you ever flip to this tab, switch to color, and you do show vertex data, you'll see that the colors on the vertices are all funky. This is information that MegaSplat uses to blend its textures efficiently. And if it's changed in any way, or broken in some way, then the problem is that it can mess up the blending, and you can get these stripes where it looks like suddenly the texture goes through 20 textures in this sort of geometric pattern and doesn't look very good. So the fix to this was always, hey, just go over and clear your colors. The problem with that is if you clear the colors, you're also clearing part of your paint job, because the base paint job for the bottom layer is stored in colors.a. So now there is an RGB clear, which will just clear those vertex colors and make sure MegaSplat is okay without erasing your paint job. So it's a fairly minor feature, but if you've accidentally messed up a mesh and you've spent a lot of time painting it, it's a really nice one to have. I was messing around. I've had this philosophy lately of trying to get every feature in the shader to be able to be used with every other feature. I think it sort of allows MegaSplat to do whatever you want it to do and be whatever you want it to be, given the feature set. One of the things I hate with a lot of shader systems is that you often have one shader that does this and another shader that does that, and then you're like, oh, well, I need a shader that does a little bit of this one and a little bit of this one, and it's like, well, I don't have that, and so unless you're savvy and can write shaders, then you're out of luck. So I've strived very hard with MegaSplat to make sure that when you're working with a shader compiler, you can just get everything going at once. So in that spirit, I said, hey, why don't I just let you have parallax mapping while you have tessellation? Like, you probably don't need it because the tessellation looks really great, but maybe it'll give you a little bit of like fine detail that you really care about. And so I did some of the math required to get that to work because they're all in different spaces and stuff. And what I discovered is it actually looks really kind of amazing. So I have it turned on here. And I'm just going to turn down the parallax height completely. So here we are. Oops, I'm not painting still. Let me just turn this off. And you saw me messing up the textures there. And let me go to a spot where you can really see this. So here we are. We're close to the ground. You can see the tessellation is looking pretty good. But now, let's go here and let's bring up the parallax height. And you'll see that increasing that parallax height, if you go too far, it breaks things, which is always the problem with parallax mapping or parallax offset. But just moving it up a little bit really adds a lot to the depth effect. And what I find is that now the combination of tessellation with this parallax is a really, it really just brings out a level of detail that I didn't realize was going to be brought out by that feature. So again, if you're not familiar with parallax mapping, it's not parallax occlusion mapping where you do 30 or 40 samples of every texture. This is just parallax offset mapping is what a lot of people call it, which is you do one extra set of samples on your diffuse textures or your height textures, which are in this case in the diffuse channels, and then you offset by the result of that. So it is, it does cost you something in terms of texture samples, but it's not crazy heavy, I guess is the point. So yeah, so that actually adds a nice little extra boost to the sense of depth there. Really helps bring out the tessellation, and also could probably help for people that want to keep their tessellation factor low because they're not integrating physics or something like that. They might actually get quite a bit out of that. So let's flip back over. We'll talk about some other stuff. Let's talk about paintable wetness and alpha test. So the clusters, texture clusters. So if you go, if you've built your own arrays at this point instead of using the ones that MegaSplat ships with, then you're probably familiar with clusters. But what they are is basically a collection of textures. So if we look at the diffuse source array here, we see we have 60 original textures in it. But what it does is the auto cluster technique will grab textures with similar names that have different numbers and make a cluster for us. And so this is what we usually paint with in MegaSplat because it eliminates tiling and it looks just really amazing. That said, you can create your own clusters. You don't have to just use the rules here. There's actually quite a bit of power in the texture cluster system. For instance, you might have these two lava textures. You can control all these noise parameters that control how they get chosen, like which one's going to get chosen. But you can also do things like angle and height. And so that can let you create sort of complex brushes that change according to the data they're being painted on. I don't think people have really dug into this system a lot yet, but there's a lot of power there. And hopefully I'll have some time to do some tutorials on it eventually. But the change in this system was before, if you created one of these manually, and you set up your texture cluster, and you had this nice little blending thing going, and then you added some textures to your array, and you were like, oh, I need to auto-generate those clusters again, and you clicked auto-generate, it would delete your manually created array. So it will no longer do that. It will keep it in the list, and you can hit this all you want. It's not going to destroy any clusters that are already there. Now, this does mean if you delete textures out, you will have to manually delete the arrays because it has no idea, that you've removed those textures because of the way the data works. But yeah, so that's a nice little thing. So hopefully more people will start using more of these beyond the auto-generated ones. That's not what I'm looking for. Let's go back here. Okay, so I fixed a bunch of bugs. Normal maps were flipped on some textures, so I went through all the normal maps on the textures and made sure they were all in the right tangent space. There was initialization error in color to splat. There was a hash calculation on the texture arrays that on the first time you ran Unity, when you opened it up, it would rebuild those arrays. This by itself doesn't cause a big problem, but the problem is that because the hash is changing, the data is changing, which means that revision control systems see these as different, and also if you included them in ACID bundles, it would be re-downloaded again. So that is fixed, and forum user helped me dig into that one and find it, which was awesome, because that is the kind of thing you really want to fix. I cleaned up and optimized some tangent generation in the train shader. I fixed some bugs in the shadows, in the render baking shaders. And before, if you were render baking a bunch of stuff and selected, I just wanted albedo, it would like spit out the normal map for you. It was just broken in terms of the selection. So that's fixed. And there was actually a really bad per frame allocation when using the runtime painting only in runtime, not in the editor. And so I fixed that as well. I have some other stuff on my to-do list. Actually just did this one. There's now an alpha for the macro texture. But I got pretty much everything that everybody's asked for done in this release. There's probably some other stuff here that I've just skipped over or forgotten about. Dug through a lot of stuff, found a lot of bugs, fixed a lot of stuff. So hopefully you'll enjoy this release, and you're still getting great results with MegaSplat. If you have any thoughts, questions, or ideas, please come to the forums, chat. It's a pretty good little community of people, and the feedback has been really invaluable in terms of guiding where this product has gone. And hopefully, if all goes well, I won't have to have like a 0.991 version. We'll be able to sort of polish off any remaining bugs and get the 1.0 out in the next couple of weeks. So yeah, thanks for listening.